Hello everyone, welcome back to our channel. In today's video, we will be discussing a new topic. So, it is in connection with the previous video lesson that we had for day 1 and day 2. Now, this will be for day 3 and day 4. So, in this video lesson, you will learn how to convert a normal random variable to a standard normal variable and vice versa, as well as compute probabilities and percentiles using the standard normal table. So, I hope that you're going to understand and enjoy this video lesson. So, let's get started. Everyone, welcome back to our channel. Now in today's video, we will be discussing about how to convert normal random variable to a standard normal variable. So these are our lesson objectives for day 3. So at the end of this video lesson, you are expected to familiarize the steps in converting normal random variable to a standard normal variable and vice versa. Then converts normal random variable to a standard normal variable and vice versa, and diligently performs the task in converting normal random variable to a standard random variable and vice versa. Okay, so let's get started. Now, conversion of normal random variable to a standard normal variable and vice versa. So we have here, let's have a review first. Steps in finding the area under the normal curve and identifying regions under the normal curve corresponding to different standard normal or z-score. Now, finding the z-score using the z formula, this our z formula is equal to x minus the population mean all over the standard deviation, where z represents the standard normal value or z-score, x is the value from the given normal distribution, and mu or it is the mean of the given normal distribution, and this one is the standard deviation of the given normal distribution. Now, the steps in transforming a normal distribution into the standard normal distribution would be: first, use the formula z is equal to x minus mean over standard deviation. 2. Substitute the given values. We have the mean and the standard deviation into the formula. 3. Simplify the expression. Let's have example 1. Now, let x be normally distributed random variable with mean is equal to 85 and standard deviation is equal to 4. If x is equal to 73, find its standard value. Okay. Now, the solution will be like this. We have to go back to our z-score formula. So, we have z is equal to x minus mean over standard deviation. We're going to substitute the values. Our mean, our normally distributed score, our normally distributed random variable, you have your 73. And our mean is 85. Our standard deviation is 4. 73 minus 85, then divided by negative 3, divided by 4 is equal to negative 3. Therefore, our z-score is equal to negative 3. Okay. So you have here, therefore, the standard value of x is equal to 73 is z is equal to negative 3. So remember, you have to consider or just imagine that 73 here is 1. It is the normally distributed random variable. So this is any value in a normally distributed random variable. Okay? In a normal distribution. Okay, a random variable or a random value in a normal distribution. Okay, let's proceed to the second example or example 2. Scores on scholarship aptitude exam are normally distributed with a mean of 72 and standard deviation of 8. Question number 1. What is the probability that a randomly selected applicant will score above 60? Letter B. What is the probability that a randomly selected applicant will score between 68 and 84? Okay, let's answer. Solution for A. What is the probability that a randomly selected applicant will score above 60? So we have here, first is sketch the normal curve reflecting the region described in A. So remember, our mean is 72. So we'll do like this one. 72 is at the middle. Then with a range of 5. Here it starts with 50 because if this is 72, this is now the division. Okay, so 72 must be at the center since it is said that it is normally distributed. So after sketching, as we can see, the given is not the standard normal distribution. Thus, we need to transform the value from the given normal distribution, 60, into the standard normal distribution. So we have here z is equal to x minus mean over standard deviation, 60 minus 72. Because 72 is our mean, our standard deviation is 8. So 60 minus 72 divided by 8, the answer is negative 1.5. Okay, so you have here z is equal to negative 1.5. Therefore, the standard value of x, 60, is z is equal to 1.5. So this is now the standard value or the z-score when x is 60. Okay, now based on the figure above, all that and the transformed value, it can be expressed as, take note of the keyword above. So we will use greater than. Okay, so the probability when x or is greater than 60 is equal to the probability when z is greater than negative 1.5. So since it's greater than, remember you need to get the total area under the normal curve is 1. So you'll have 1 minus 0.0668. Then the probability when x is greater than 60 is equal to 0.9332. Okay. Therefore, the probability that a randomly selected applicant will score above 60 is 0.9332 or 93.32%. So this is now the answer. And this is now the shaded part. Okay? I hope that you were able to follow the steps. It is just simple. Now let us proceed to the solution for letter B. What is the probability that a randomly selected applicants will score between 68 and 84? Now, we have tried solving problems, getting the area under the normal curve given the two z-scores. Now, this time, we are given two values of x or randomly selected variable or normally random variables. Normal random variables, I mean. So, since here 72 is our mean, so you have that one. Then based on our graph, starting here, our 68 is here and our 84 is somewhere here. So we're going to shade this part because we are asked to get the probability or the area between these two scores or probability between these two random variable. Okay, now sketch the normal curve reflecting the region described in B. So we have that already. Now, transform the value from the given normal distribution 68 and 84 into the standard normal distribution. So when x is equal to 68, z is equal to x minus mean over the standard deviation. 68 minus 72, that's over 8. Z is equal to negative 0.5. Okay, so our z-score is negative 0.5. So next, when x is equal to 84, z is equal to x minus mean over standard deviation. That is 84 minus 72 divided by 8. Then z is equal to 1.5. Next step, thus the standard values when x is equal to 68 and x is equal to 84 are z is equal to negative 0.5 and z is equal to 1.5 respectively. Now, what is the probability that a randomly selected applicants will score between 68 and 84? Now, as shown in the figure above and the transformed value, it can be expressed as, the previous figure, it can be expressed as the probability when x is greater than 68 but less than 84, or the probability when z is greater than negative 0.5 but less than 1.5. We're going to get the area in between the two z-scores. We have 0.9332 minus 0.3085. Then we're going to subtract that one. This is now the resulting value. The probability when x is greater than 68 but less than 84 is equal to 0.6247. Okay. So we have here, therefore, the probability that a randomly selected applicants will score between 68 and 84 is 0.6245 or 62.47%. Look at that. So this is now the answer and this is now the graph. Okay? So far so good. Next, example 3. Assume x is normally distributed with a mean of 15 and a standard deviation of 5. Determine the value for x that solves each of the following. A. Probability when x is less than x is equal to 0.2810. The probability when x is greater than x but less than 21 is equal to 0.8185. Letter C. The probability when x is greater than x is equal to 0.9222. Okay. Now solution for A. Let's start. So in the given, we only have the mean and the standard deviation. We lack the z-score. Thus, the first thing is to find the z-score. Hence, you have it here. The probability when x is less than x is equal to 0.2810. Or P, the probability when x is less than x is equal to the probability when z is less than z is equal to 0.2810. So, the probability when z is less than z is equal to 0.2810. Then we're going to look at the z table. We're going to look for the area and locate the z-score that is. Then we will have the z-score as negative 0.58, which has an area of 0.2810. Okay. Next would be, note that we have the z-score. Compute for x by using the transform z formula we have. So remember the z formula that we have. Our z formula is z is equal to x plus the mean over the standard deviation. Now cross multiplication, we can have this one. X is equal to mu or mean plus the z-score times the standard deviation by manipulating the formula of the z formula in terms of x. So x is equal to 15 plus z is negative 0.58, then standard deviation is 5. Then x would be 12.1. Okay, for a moment. Okay, so we just simply substitute the values. Okay, therefore with mean is equal to 15 and standard deviation equals 5, the x value that solves P, probability when x is less than x, is equal to 0.2810 is 12.1, or P, the probability when x is less than 12.1 is 0.2810. So, okay, that's it. I hope you were able to follow. Now let us proceed to this letter B. In this problem, there are two x values. One is given while the other one is unknown. In this case, let us first transform the given x value into z-score. We have, when x is equal to 21, z is equal to x minus mean over the standard deviation. So, we have here, z is equal to 21 minus 15 over 3. Then z is equal to 2. Okay. Now at this time, let us find the z-score of the unknown x value. Thus, you have here the probability when x is greater than x but less than 21 is equal to 0.8185. Or you can have, this is just the same as the probability when z is greater than z but less than 2 is 0.8185. The next would be the probability when z is less than 2 minus the probability when z is less than z is equal to 0.815. The answer would be 0.9772. We are going to get the area, the probability when z is less than 2, and that is 0.9772 minus this one. So we'll have 0.08185. The resulting answer, P, the probability when z is less than z is equal to 0.1587. Then we are going to look at the z table and find the z-score that has this area. So the z-score that has this area is negative 1.00. Okay. So let us now compute for the unknown x value. So to compute the unknown x value, because we are given the mean and the standard deviation as well as the z-score. So x is mean plus the z-score times the standard deviation. So you have x is equal to 15 plus, this is our z-score, negative 1.00. 5 is our standard deviation. Then the answer is 10. X is 10. Therefore, with mean is equal to 15 and standard deviation 5, the x value that solves probability when x is greater than x but less than 21 is equal to 0.8185 is 10, or the probability when x is greater than 10 but less than 21 is 0.8185. Okay, so I hope that we're able to follow. It's quite tricky, but it's when you analyze it well, it's all right. Okay, solution for C. First, let us identify the z-score that solves probability when x is greater than x is equal to 0.9222. Then the probability when x is greater than x is equal to the probability when z is greater than z is equal to 0.9222. Then the probability when z is greater than z is equal to 0.9222. Then you have probability when z is greater than z is equal to 1. Remember, this is greater than. So you have 1 minus the probability when z is less than z is equal to 0.922. Then you have here the probability when z is less than z, 1 minus 0.9222 is equal to 0.0778. And then we are going to locate the z-score. Look for the z-score that corresponds to this area under the z table. So the z-score that we're gonna find out is negative 1.42. Okay. So with mean is equal to 15, standard deviation 5, and z score is equal to negative 1.42. We can now solve for x value. Thus, x is equal to mean plus the z-score times the standard deviation is 15 plus negative 1.42 times 5. Then x is equal to 7.9. So therefore, with mu or with mean is equal to 15 and standard deviation is equal to 5, the value of x that solves probability when x is greater than x is equal to 0.9222 is 7.9, or the probability when x is greater than 7.9 is 0.9222. Okay, I hope that you are able to still follow. Now let us proceed to developing mastery. This time you're going to answer on your math activity notebook. Assume the random variable x is normally distributed with mean is equal to 86 and standard deviation is equal to 5. Find the probability. Number 1, probability when x is greater than 92. 2, probability when x is greater than 70 but less than 80. Okay, now let us proceed to application. Suppose that the distribution of weights of Filipino females 20 to 30 years old is normal and has a mean weight of 65 kilograms with a standard deviation of 10 kilograms. what is the probability that a randomly selected Filipino female, 20 to 30 years old, weighs less than 50 kilograms? Okay, you're still going to answer this in your math activity notebook. Now, for generalization, I want you to answer these two questions. What are the steps in converting normal random variable to a standard normal variable and vice versa? Number 2, how are we going to convert normal random variable to a standard normal variable and vice versa? Okay, in your assignment, answer this question: what are the steps in probabilities and percentiles under the normal curve? Okay, so that ends our lesson for day 3. I hope that you have learned something in day 3 lesson. Now let us proceed to day 4. Okay, lesson objectives for day 4. At the end of this video lesson, you will be able to state the steps in computing the probabilities and percentiles under the normal curve. Remember, this is your assignment on the previous day. Compute probabilities and percentile using standard normal table, and demonstrate patience, accuracy, and discipline in answering the activities. Now, probabilities and percentiles using the standard normal table. Okay, let's have a quick recall. Rewrite each of the following expressions in a card of size 2 by 1. Okay, now I will have another instruction for this one. Using the Z table, make 5 pairs of cards and creatively glue this in a long bond paper. This is the original instruction. However, I will going to modify the instruction. I want you to pair it on your notebook. Just pair these cards. You call this square. Oh no, this rectangular box. Okay, I want you to pair with this. You have here 5 z-scores and you have 5 areas. So for example, this are you going to write like z is equal to negative 1.01. So you are going to write the corresponding area, whichever area here. So you will use your z table. Okay, that will also be checked. Okay, now what is percentile? So in day 4, we will be discussing about percentile. So we have here a percentile is a measure used in statistics indicating the value below which a given percentage of observations in a group of observations fall. Now it is a measure of relative standing as it measures the relationship of a measurement of the rest of the data. For instance, your statistics grade for the quarter is 89 and is at the 90th percentile. It means that 90% of your classmates were graded lower than 89 and putting you in the top 10%. Now the alternative to percentile would be the raw score, say 14 out of 20. Is 14 over 20 a good score, a bad score, or an average? Now we do not know unless we compare it with scores other people achieve. Thus, this is what a percentile score does for us. There are steps in finding the z-score given the percentile. So first is you write the percentile as probability. Then locate the newly found figure or area in the z-table. Then identify the z-score. Then illustrate the normal curve reflecting the region being described. Okay, let's start with example 1. Find the 95th percentile of the normal curve. Okay, now the solution. By definition, percentile 95 or 95th percentile, this is how you're going to write that, means locating an area before or below the point. You want to know what the z value is at this point. Thus, let us rewrite the 95th percentile into probability that is 0.9500. Okay, by the way, it's 95th percentile is the same as 95 over 100. So 95 divided by 100, that is 0.9500. That is automatically your probability or area. Then we will look for the z-score. Okay, I mean this is already the area. 90% of the normal curve. Okay. Then we have here, refer to the z table and look for 0.9500. Once found, identify the z value by considering the leftmost column and the topmost row. Unfortunately, there is no 0.9500 in the table. So it is between 0.9495 and 0.9505 with corresponding z-scores of 1.64 and 1.65. Since 0.9500 is halfway between 0.9495 and 0.9505, we will take the average of their z-scores. Thus, the z-scores 1.64 plus 1.65 divided by 2, that will give us 1.645. Okay, this is 1.6. Remember that is 0.9500, so that is here. So halfway. So you will just going to divide it into 2. Okay, the two z-scores between 1.64 and 1.65. Okay, and this is now the sketch. This is now the graph. Therefore, 95% of the distribution lies below z is equal to 1.645, and this is here 95%. This is the 95th percentile. Okay, let us proceed to example number 2. Find the 67th percentile of the normal curve. Now, 67th percentile means locating an area below the point. You want to know what the z value is at this point. Thus, let us rewrite the 67th percentile into probability, that is 0.6700. Again, that is just simply 67 divided by 100. So, use the z table and look for 0.6700. Once located, identify the z-score from the leftmost column and the topmost row. So that it is 0.44. So you have here 0.6700, exactly this is the area. So we can easily solve or find the z-score, which is 0.44. Okay, now this is now the graph. 0.044 is somewhere here. Then this is the shaded part, and this is now the 67%. Therefore, 67% of the distribution lies below z is equal to 0.44. Okay, I hope everything is going well. Now, let's proceed to third example. The height of 12-month-old boys is normally distributed with the mean 76.4 and the standard deviation is 2.9 centimeters. What is the 10th percentile for height? Okay, for the solution, find the z-score for 10th percentile. Again, there is no 0.100 in the z table. Instead, it lies 1/5 of the way from 0.1003 to 0.0985. This corresponds to negative 1.28 and negative 1.29. Thus, to find the 1/5 of the way, z is equal to negative 1.28 plus 1/5, negative 1.29 minus negative 1.28. Then, the answer is z is equal to negative 1.282. Okay. Example 3. Now, at this time, let us find the 10th percentile for height by using the z-score found in the z formula. So, we have x is equal to mean plus z-score times the standard deviation. X is equal to 76.4 plus negative 1.282 times 2.9. Our x is 72.68. Therefore, 10% of the 12-month-old boys are shorter than 72.68 centimeters. Moreover, 90% of them are taller than 72.68 centimeters. So this is how you're going to interpret at the end. And this is the sketch, 10%. Okay, so this is where 72.68 centimeters is located. Now, developing mastery. You're going to answer this one on your math activity notebook. Situation. Rodrigo earned a score of 943 on a national achievement test. The mean test score was 850 with a standard deviation of 100. What proportion of students had a higher score than Rodrigo? Assume the test scores are normally distributed. If there were 100,000 students who took the test, how many would be expected to have a higher score than Rodrigo? Then application. The normal distribution is widely used in understanding distributions of factors in the normal population. Because the normal distribution approximates many natural phenomena so well, it has developed into a standard of reference for many probability problems. Some of the real-life situations are the following. Like, for example, height of the people, fair rolling of dice, tossing a coin, IQ level of a population, rise and fall in the prices of shares in the stock market, blood pressure. Okay, so that is just simply an application, and you might be wondering why we are studying this, or why this lesson is part of our curriculum. Now, generalization, I want you to answer this two questions. Number one, how are you going to compute probabilities and percentiles using the standard normal table? Number two, enumerate the steps in computing probabilities and percentiles using the standard normal table. Okay, and in your assignment, in your math activity notebook, answer the question. Number one, what is random sampling? Number two, what is the difference between parameter and statistics? Okay? Okay, so the evaluation should come first before the assignment. However, I'll read now the evaluation. You're going to answer this in your activity notebook. So this is week 4, day 4. Now, direction. Read and analyze statement carefully. In your activity notebook, write the letters of your choice, but you also have to show your solution. Number 1, what is the area under the normal curve? But there are questions that doesn't need solutions, so you leave it there. Number 2, which of the following is the curve symmetrical to? A. I'll repeat. Number 1, what is the area under the normal curve? A, 0, B, 1, C, 2, D, 3. Number 2, which of the following is the curve symmetrical to? A, mean, B, variance, C, standard deviation, D, area. Number 3, what is the area when the z-score is 0.00? A, 0.00, B, 0.50, C, 0.10, D, 100. Number 4, find the area when the z-score is above 1.92. A, 0.0274, B, 0.9726, C, 0.5129, D, 0.329. Number 5, which of the following z-score makes the notation a true statement? The probability when z is greater than z but less than 3 is equal to 0.1574. A, 0, B, 1, C, 2, D, 3. Number 6, given the x is normally distributed with mean is equal to 85 and standard deviation is equal to 6. Find the z-score when x is equal to 97. A, z is equal to 1, B, z is equal to 2, C, z is equal to 3, D, z is equal to 4. Number 7, what is the probability of x is less than 208 when mean is 178 and standard deviation is equal to 15? A, 2.0, B, 0.0228, C, 0.5000, D, 0.9772. Okay, number 6, given the x is normally distributed with mean is equal to 85 and standard deviation is 6, find the z-score when x is 97. A, z is equal to 1, B, z is equal to 2, C, z is equal to 3, D, z is equal to 4. Number 7, what is the probability of x when less than 208 when mean is 178 and standard deviation is 15? A, 2.00, B, 0.0228, C, 0.500, D, 0.9772. Number 8, assuming that the heights of college male students are normally distributed with a mean of 69 inches and standard deviation of 3 inches. If a student is chosen at random, what is the probability that his height is less than 65 inches? A, 0.0918, B, 0.3707, C, 0.9082, D, 0.9991. Number 9, the weights of the contents of a cereal box are normally distributed with a mean weight of 20 ounces and a standard deviation of 0.07 ounce. Boxes in the lower 6.3% do not meet the minimum weight requirements and must be repacked or repackaged. What is the minimum weight requirements for a cereal box? A. 20 ounce, B. 19.99 ounce, C. 19.89 ounce, D. 19.79 ounce. Number 10. In a large section of a statistic class, the points for the final exam are normally distributed with a mean of 72 and a standard deviation of 9. A student will receive an A grade if he or she is in the top 10%. What will be the possible lowest score in the final exam that would qualify a student for an A? A. 72, B. 84, C. 60, D. 54. Number 11. What is the value of the 82nd percentile? A. Z is equal to 0.92, B. Z is equal to 0.718, C. Z is equal to 0.518, D. Z is equal to 0.315. Number 12. Solving for 48 percentile, its z-score lies between what two z-scores? A. Z is equal to negative 0.48 and Z is equal to negative 0.49. B. Z is equal to negative 0.47 and Z is equal to negative 0.48. C. Z is equal to negative 0.04 and Z is equal to negative 0.05. D. Z is equal to negative 0.05 and Z is equal to negative 0.06. Number 13. When the probability you are looking at is not in the z-table, how will you find its z-score? A. Randomly choose any probability from the z-table. B. Look for another z-table, maybe it is in the new z-table. C. Choose the closest probability. D. Do not answer the problem. 14. Which of the following statistics always corresponds to the 75th percentile in a distribution? A. Third decile, B. Third quartile, C. Seventh decile, D. Seventh quartile. Number 15. In a survey of men in the Philippines ages 20 to 29, the mean height was 69.6 inches with a standard deviation of 3 inches. What height represents the first quartile? A. 68.57 inches, B. 67.59 inches, C. 66.59 inches, D. 65.57 inches. By the way, just research about quartile in relation to percentile, so you can answer. Okay, quartile means 25th, by the way, or by quarter from the word quarts, root word quarts. Okay, so that's it. So this ends day 4. So thank you so much for watching, and I hope that you were able to understand our lessons for day 3 and day 4. And if you have not subscribed yet in my channel, please don't forget to subscribe. To end this video, let's have a math code. Mathematics is the Music of Reason by James Joseph Sylvester. Okay, so thank you so much, and God bless us all. Bye.